Have you ever wondered that how your mobile phone's screen changes its orientation on its own when you flip it? That's all because of the principle on which this MPU6050 works. So in this video, we are going to uncover the details of this MPU and its proper working. And we will also see what is DMP inside this MPU6050. So let's get started. So this model is called MPU6050, which is basically an IMU. IMU stands for Inertial Measurement Unit, okay, which measures the orientation and rotation of an object in 3D space using a combination of accelerometer and gyroscope. So accelerometer measure your linear acceleration plus tilt, and gyroscope measure the rotation about the three axes x, y, and z. And some IMUs also consist of magnetometer, but this MPU6050 does not contain any type of magnetometer. That is why it is called 6-axis IMU, because it gives 3 values for the accelerometer and 3 values for gyroscope. Now let us move on to the details of accelerometer, gyroscope, and DMP. Now let's discuss about the gyroscope. So the gyroscope present in the MP6050 is called the MEMS gyro, and this MEMS stands for micro electromechanical system, right? And these sensors produce the voltage when a particular axis is rotated. That is why they are called electromechanical. Mechanical because they are rotated, and electro because they produce voltage. And the voltage that the sensor are producing is sampled using the 16-bit ADC present in the MP6050, right? Because the microcontroller cannot read the voltage directly, they need digital values. So this ADC converts the voltage into the digital values. Now coming on to the accelerometer. So this unit comes into play when the object is accelerated along a particular direction, and it measures the inertial force and not the actual motion, okay? And the direction of the inertial force and the acceleration are opposite to each other. Suppose this object is accelerated along positive x direction, then the inertial force will be acting along negative x direction, okay? And this accelerometer also treats the gravity as an acceleration along the z-axis. And I will also show you later on that if the MP6050 is still on a level surface, then it will show a value of 1 along z-axis, okay? And that 1 value will represent 1g. G means 9.81 meter per second square acceleration due to gravity. Now here is a note for you. The MPU6050 module also consists of DMP, Digital Motion Processor. So what does this DMP do? It takes the raw values of gyroscope plus accelerometer and do some sensor fusion to output values like pitch, roll, yaw, quaternions, and many more. Because you need to note that the accelerometer values are noisy in nature and gyroscope values drift over time, right? So in order to tackle that, the DMP outputs the stable values by applying some filters like complementary filter, Kalman filter, etc. Now let's have a look at the program to display the values of acceleration. So wire library is used to establish the ITC communication protocol between MPU and Arduino. And this MPU6050 LAT library handles all your calculation for the values of acceleration, tilt angles, and all other quantities. So we do not need to calculate them manually one by one. And in this line, we are telling the MPU to use the ITC communication protocol using MPU wire, right? And in the setup section, here we are setting up the ITC communication using wire.begin. And in this line, we are initializing the MPU using MPU.begin. If the status is 0, it will be okay. Otherwise, if status is not 0, then it will throw an error. And in this line, we are calculating the offsets for MPU6050. As I've already explained you that accelerometer values are noisy in nature and gyroscope values drift over time. So this line handles all those errors and removes them. Now coming on to the loop section, in this section we are updating the MPU using MPU.update, right, for the each loop iteration. And this MP6050 LAT library provides us this built-in function for the calculation of acceleration along all these three directions x, y, and z. So we can call these functions directly and use them in our program. And we are printing these acceleration values on the serial monitor using serial.print, okay? And we can also call these functions for the calculation of angles, mp.getAngleX, getAngleY, and getAngleZ. So all these functions have already implemented the sensor fusion and filters like Kalman filter, complementary filter, and that is why they are able to give us the stable output values. Now let's upload the program in the Arduino and see the output on the serial monitor. Now let's open the serial monitor and you will see the values of acceleration along all the three directions. So it is calculating the offsets. And you can see the acceleration along x and y direction are 0, but acceleration along z direction is 1. Now here 1 is representing that the acceleration along z is plus 1g. G means acceleration due to gravity, which is 9.81 meter per second square. So if I move this MPU6050 along y direction, this is along y direction, So you can see the acceleration is changing. And if I move this MPU6050 along X direction, the acceleration also changing along X direction. Okay. So this is how you can measure the values of acceleration along all the three directions. Now let us talk about the pinout of this MPU6050. So it has two pins for power, VCC and the ground. SCL stands for serial clock and SG stands for serial data, right? Now actually these two pins are used for the I2C communication between this MPU and microcontroller like Arduino. And this MPU6050 is actually an I2C communication device which communicates with the Arduino through I2C communication protocol, right? And that Arduino assigns a different I2C address to each of the I2C device. And SCL is used for the timing synchronization between the Arduino and this MPU6050. And SDA is used for sending actual data. And we connect this SDA to pin number A4 of Arduino and SCL to pin number A5 of the Arduino. Because the Arduino Uno has only two pins for I2C communication, A4 and A5, which are the hardware I2C communication pins. Now coming on to XDA and XCL. XDA stands for extra serial data and XCL stands for extra serial clock. So these two pins are the secondary I2C bus on this MPU6050 to connect another I2C devices like magnetometer, pressure sensor, etc. Okay, and you may ask why this MPU6050 having these two pins. So the reason is simple, because this MPU6050 has built-in DMP. So this DMP can read the data from external sensor and fuse the reading and give you a single stable output. Now coming on to AD0 pin. This pin is used when you are using two MPUs with a single microcontroller like Arduino. So suppose I am having another MPU here. So what I will do, I will connect the SDA pin of both the MPUs with a single A4 pin of Arduino and SCL pin of both the MPUs to the single A5 pin of Arduino, right? And if AD0 pin is connected to ground, ground means low signal, then the I2C address of that MP will be 0x68. This is a hex address, right? And if AD0 is connected to VCC, VCC means high signal, then the I2C address of that MP will be 0x69, because in I2C communication, the address of all the I2C devices should be different. And remember that you cannot have AD0 pin of both the MPUs either to be connected to ground or VCC, right? Because in that case, the I2C address of both the MPUs will be same, and Arduino won't be able to identify which MPU to communicate with. So you must keep the AD0 pin of one MPU to ground and other to VCC, and vice versa. And suppose you write MPU.initialize 0x68, then Arduino will choose that MPU whose AD0 pin is connected to ground. Okay. And if you write MPU.initialize 0x69, then Arduino will choose that MPU whose AD0 pin is connected to VCC. Okay. Now the last pin on this MPU is INT pin, which stands for interrupt. So actually your Arduino keeps on asking this MPU for the new sensor data again and again. So that process takes time and wastes CPU cycles. So this interrupt pin solves that problem. This INT pin goes in high state and low state only when the new data is detected by this MPU6050. Okay, and in this video I am going to limiting myself on these pins VCC, ground, SCL and SDA. And if you want me to use these last pins XDA, XCL, AD0 and INT pin, then you can comment down below yes, and I will make a separate video by using these 4 pins. So if you learned something new from this project, hit the subscribe button and press the bell icon so you never miss my latest video tutorials. And if you have any doubt regarding this project, comment down in the comment section and I will see you in the next video.